Haoles. Okay? Do Haoles form the majority of the population within Hawaii? Not on Molokai. Yeah, we won't talk about Waikiki, right? Okay? Not on Molokai. So my question for you is this. How well do these individuals represent the genetic diversity, if we correlate genetic diversity with, external appearance, how well do they represent the genetic diversity of the Hawaiian Islands? Not well at all. This is skewed. In fact, if you were to allow this population to grow and expand and go for thousands and thousands and thousands of years, so you had the Gilliganites, right? We'd be having this argument about where the Gilliganites came from, okay? Would you infer they came from Hawaii? No, it'd be Southern California, right? Okay. Okay. So this is the point, okay? And sorry to spend so much time on it, but you've really got to recognize that this notion of subsampling populations has devastating effects for how we do this sort of science. Okay, number 4. Did the colonizers arrive to a genetic island? This is the notion that when the colonizers arrived, they could have arrived to where there was no one else around, so that they had the ability to reproduce and carry that same genetic signature. Okay? But what's the implications if they arrived and there were other individuals there? You begin to get introgression, you begin to get genetic swamping. And so what you would have to do is convince me that this is not a problem. How do you account for genetic mixing after the Book of Mormon ends? Okay, we know that the Book of Mormon ends about 400 AD. We've got about 1,600 years where there have been other individuals who have input their genes into that population. As a reviewer sitting on an NSF panel, you have got to convince me that this is not a problem. What are the effects of a limited geographic view of the Book of Mormon? Now, the point here is that if you have a limited geographic view, so that we're not talking about North and South America in their entirety, but we're talking about a smaller geographic region, perhaps around Mesoamerica or any place, the notion is you will have a smaller population size. The smaller population size is more susceptible to swamping. You are less likely to find residual populations of these genetically pure Lamanites, whatever they might be. And in terms of genetics, what this means is if you could take a look at the overall picture of the genetics on North and South America, what this might mean is that the colonizers were nothing more than a small genetic blip. And so the issue comes up, can you pick up this genetic blip in your studies? Who are the living genetic descendants of the Lamanite lineage? As a good scientist, as my brother would say, you would have to, a priori, identify who you are going to test in this analysis. Well, who should they be? Well, this is what we've got. We've got an introduction to the Book of Mormon, which says, after thousands of years, all were destroyed except the Lamanites, and they are the principal ancestors of the American Indians. We further have various populations, various groups of people which have been associated as being descendants from Lamanites by various church leaders over periods of time. And we're going to have Dr. Peterson, who can speak to some of these issues in more detail if you're interested in them. Current evidence, as I say, suggests that Native Americans have a genetic history representative of Asia and not the Middle East. But what I want to point out is this. Number 1, the introduction to the Book of Mormon was a commentary. It was a commentary added in 1950. It was a commentary which was based on the best understanding of the brethren at the time. There is nothing within the text of the Book of Mormon which specifically identifies who the genetic descendants might be. Okay, so this is an issue you've got to deal with. You've got to convince me who these descendants might be. Now, this is, of course, a bone of contention. And this is where a lot of the brouhaha has been based on, has been arguing this point. But I don't want to jump into this in any more detail here. Number 8. Okay, we're going up to 12. So I told you it was going to hurt your head, but bear with me here. Okay. Who are the living genetic descendants of the Middle Eastern source population? Everybody is so worried about who are the descendants of these Lamanites. They're not thinking so much about who are the descendants of the source population. Because just as you have introgression and the potential for founder effect and the potential for all these other things going on with your colonizers, you got the same thing going on in your source population. So you've got to convince me that it is reasonable to jump on a plane, go to Jerusalem, sequence a bunch of people, and make the inference that that is what the genetic signature looked like when Lehi left. Okay? And so this is the notion that you are inferring that a modern sampling of Middle Eastern lineages accurately represents the genetic heritage of the source population. How does natural selection influence your results? Now, Dr. McClellan, who is here, is actually a recognized international authority on looking at DNA information and detecting whether selection is present or selection is absent. So pleased to have him here as one of our panelists today. And this is a notion that a particular genetic marker may become more prevalent or less prevalent if it is linked to a feature that natural selection acts upon. Okay? I'm going to give you a more complicated example. Okay, these are jelly bellies. They're more complicated than the gumballs. If you're like me, I go to Costco and I buy one of those great big things of jelly bellies. You ever do that? Okay, they're wonderful things. And you sit there in front of the TV watching Gilligan's Island, and you're eating away blissfully, and then what happens? Oh, you get a cappuccino, you get a jalapeno, you get one of these other very bizarre flavors. Okay, so the notion is if I had it my way, I'd sit there and pick all these things and throw them out. Okay, and that's essentially what natural selection is doing. Okay, but the problem is, if it turns out that the percentage of jalapeno in your population is what you've used to define your population, and natural selection has thrown it away, then you've got a problem, right? Okay, so this is just another problem. How does mutation influence your results? Mutation is simply the notion that we have a certain number of genetic markers we start with, but over time, due to mutations, due to the DNA replicating machinery, you will have changes in those markers. So what this means is that your source population is going to change over time. Your colonizing population is also going to change over time. And this is something we've got to deal with. How does recombination influence your results? Recombination is this notion that you can have two genetic markers in a sexually reproducing population. These can do something called crossing over. And this leaves you with a mixture. And so instead of having just a red and a green, you have two genetic markers which are a mixture of both. Well, the problem with this is that it is not altogether clear when you see that that is what you are seeing. What it can look like is something altogether different. Now, I'm happy to have Dr. Crandall on the panel today because he really is one of the world's authorities on using and detecting recombination within phylogenetic studies. His research has been the most cutting-edge work in this area. And so what does this do? This mixes and confounds evidence of ancestry. Number 12. You guys have been so good. We're on the last one. Hang on. Gene history versus population history. This is the notion that when we use DNA as a genetic marker, what we are really doing is reconstructing the history of that DNA marker. And we are saying that the history of that DNA marker is the same as the history of the organisms which happen to carry that DNA marker. Now, for some very complicated reasons, and we won't get into them here, it turns out that this is not always the case. And we know this. How do we know this? I can do a phylogenetic study on walking sticks, and I can use 5 genes. And each one of those genes can tell me a different story. Some of those genes might tell me more of the similar patterns, some might tell me more different patterns, but the notion is that this kind of naive notion that the molecular data are straightforward and tell you all the same story is really not what the case is. And this is why additional DNA markers and innovation in analysis are required. Modern population genetic studies are moving in this direction where they're taking a look at more information to try and get at these historical things. Well, this brings up what I would like to call the DNA fallacy, and this is number 1. DNA analysis does not require careful experimental design. This is the notion that if I say I have a conclusion based on DNA, I must be correct because I use DNA. And what could be more scientific than DNA? Okay, what you've got to recognize is that the National Science Foundation receives every year literally thousands of proposals from established researchers who say, I will use DNA to do something. And of those, at least a good 50 of them are immediately cut out of the top because a panel will say, no, you really can't use DNA to do that after all. Okay, we recognize this within the scientific community. It needs to be recognized, I think, in the community at large. Second fallacy, DNA provides straightforward, unambiguous, and internally consistent information about the past. As I mentioned earlier, no, it doesn't. Okay? It is not always consistent. It is very often ambiguous, and it is open to further testing.